Hi and welcome back to the channel. I'm Hassan and today we're going to be talking about partial fraction decomposition. It's a subtopic of algebra. Okay. So what is partial fraction? Partial fractions basically break down one rational expression into simpler ones. So let's say you have an expression like this right here, x plus 5 over x plus 2 times x plus 3. Okay. Now I can write this expression into simpler expressions like this, x plus 2 plus b over x plus 3. So now what this a is a constant and b is also a constant. It can be any constant and I have to find these constants. Now what I can do is, moving forward, I can just multiply this entire equation by the denominator right here. So x plus 2 times x plus 3. Multiplying this side with x plus 2 x plus 3, I'm going to be getting rid of all of this. I'm just going to be left with x plus 5. Now for this side, a over x plus 2 multiplied with this denominator will give me a times x plus 3 because the x plus 2 will cancel out, and b into x plus 2 because the x plus 3's will cancel out. Now I have to expand this. So ax plus 3a plus bx plus 2b, right? And now I can add this x plus 5. Now I can compare the coefficients. So what I can do is, let's say the coefficient of x is 1, so I can say 1 is basically equal to a plus b, and 5 is equal to the constant, which is 3a plus 2b. Now I can just make a bit of space right here for me to work with. So let's say I can add this here, I can add this here. Now I can just solve for, let's say, a. So a is going to be 1 minus b. I can put this a right here into this equation, 1 minus b plus 2b, to get 3 minus 3b plus 2b, which is basically 3 minus b equals 5. This will give me negative 5 minus 3 is 2, negative 2 will be b, and my a will be 1 minus negative 2, which is 3. So I can say that my value of a is 3, my value of b is negative 2, so I can put it right here, which is a over x plus 2. So I can say 3 over x plus 2 plus, or I can just write it like this, minus 2 over x plus 3. So this right here basically equals x plus 5 over x plus 2 times x plus 3. So notice how we went from this complex, a bit complex fraction to these two simpler ones, right? And you use these for integration, for algebra, and for other purposes. Now let's say because there are some variations, let's say instead of this it was written x plus 5 over x plus 2 times x plus 3. So now this is a repeated denominator, right? So instead of writing a plus b, I'm going to be writing a over x plus 2 plus b over x plus 3 plus c over x plus 3 squared. So whenever you have a repeated denominator, you're going to be writing x plus 3 and then x plus 3 squared. And let's say another scenario is if this was a quadratic instead of a linear function. So let's say x squared minus 3x plus 4, for example. So in this case I'm going to be writing a over x plus 2, because whenever your degree of the denominator, whatever your degree of the denominator is, you have to keep the degree of the numerator one less than that. So let's say if I have a linear denominator, I'm going to be writing a constant in the numerator. If I have a quadratic denominator, I'm going to be writing a linear numerator. So because my denominator right here is quadratic, so my numerator will become a linear function. So not a quadratic, not a constant, but a linear with a degree of 1, and degree basically refers to the highest power of x. So now I'm going to be writing bx plus c. Okay. And you might wonder that why didn't I write, because this right here is also a quadratic function, right? So I could have written cx plus d right here, right? But I don't write this because I only care about the function inside the square, because when it is written like this, it's being repeated, it's being squared, or whatever the power is, it's basically square. So I don't care about the power, I just care about the function inside. Okay, so I'm going to be writing c instead of c x plus 3. But when I have a function like this written, expanded in the form of x squared, then I'm going to be writing bx plus c. Now the procedure is similar. You're going to be multiplying the entire equation with this denominator right here, and this will all cancel out. And for this I'm gonna be getting a times, let's say, x squared minus 3x plus 4 and for this I'm going to be getting bx plus c times this linear function, that is x plus 2. I can multiply these two terms together to get 4 terms, and I can get 3 terms from this, and then I can compare the coefficients. So this is it.